Hello again. Today we are solving inequalities, not equations, inequalities. But first we need to look at what's really happening when we solve equations so we can compare what happens when we solve inequalities. So if we have an equation, let's say A equals B, for quite a bit of time now we've been adding and subtracting and multiplying and dividing things on both sides to get what we want. So for example, we may be adding something to both sides to get what we want, and when we do that, the equal sign remains an equal sign because we have not disturbed the equality of the left side and the right side. And we have not disturbed the equality when we subtract either, nor have we disturbed the equality when we multiply both sides or divide both sides by something, as long as m is not 0. So in all of these cases, starting with A equals B, we have preserved the equality of the left side and the right side. Now in inequalities, first of all, the statement A less than B is kind of a general statement. It's not a super exact statement because this statement is not telling you how much A is less than B. A could be very close to B, or A could be very far away from B. This statement is very general. It's just saying that A is less than B, but not by how much. Not by how much. So if we take an inequality and we add or subtract or multiply or divide something on both sides, the question is, what happens to the inequality? Is the inequality preserved? Is the left side still less than the right side? Or is the left side now greater than the right side? Or does something else weird happen? That's the question. Does it happen the same way whether we add or subtract, or whether we multiply and divide? Or does something different happen when we do this versus this? Or does the same thing happen when we do all four things? That's what we're going to investigate. So I'm going to use a number line for us to discover what happens. So let's say A is here and B is here, and this is 0. So we have A less than B. Now if I add a positive number to both A and B, I now have A plus C and B plus C. And since I'm adding a positive number, both values will jump to the right on the number line, right? So now A plus C is here and B plus C is here. But since I added the same value, positive value to A and B, they both move equal distance to the right. So of course, A plus B will still be less than B plus C. In fact, they will actually be the same distance away from each other than A and B were. So if C is a positive number, the inequality is preserved. There is no change to the inequality. Left side is still less than the right side. Now let's say I subtract some number, then they both jump to the left. A minus C will be here, B minus C will be here, and they will be the same distance from each other as A and B were. So again, I'll underline this because if you add a negative number to both sides, if C is negative, same thing as subtracting, then the inequality is preserved. So no matter it doesn't matter if C is positive or negative. If you add it to both sides, the inequality is preserved. So nothing weird happens yet. Now, let's take the case of multiplying both sides by something. And we'll say that c is a positive number, okay? So if I multiply both sides by c, I mean a and b by c, a will get, well, a is negative here. So if I multiply by a positive number, I'm going to get a negative product, right? Negative times positive. And the absolute value of that product will be larger than before. So AC will actually end up over here. And BC will end up over here. So the distance between AC and BC will be greater than the distance between A and B. But that's not the main issue. All we care about is the left side still less than the right side? Yes, AC is less than BC. So the inequality is preserved. So when I multiply both sides of an existing inequality by a positive number, nothing changes. However, I didn't inspect the case where both are positive, so let's try that. Because this might make a difference. What if A and B are positive, and A is less than B? I multiply by C, so product AC is over here. I multiply B by C, and since B starts out larger than A, the product will jump, much farther than AC. So the distance here will be greater than the distance here. But all we care about is the left side less than the right side? Yes. AC is still less than BC. So same thing does happen here. Now what if they're both negative? AC will end up here, BC will end up here. The distance here will be greater than the distance here, but all we care about is AC less than BC? Yes. So again, same thing happens. So we can be certain that if we multiply both sides by a positive C, the inequality doesn't change. Okay, now the last case we need to check is multiplying both sides by a negative. So let's use a negative number. And we'll have A start out negative and B start out positive. And I'm going to multiply each of them by C, a negative number now. So when I multiply this A, which is negative, by a negative number, the product is positive, right? So the product will jump over here. When I multiply this positive B by a negative number, the product will jump over here. Okay, we have created a different situation now. AC is no longer less than BC. It is BC now that is less than AC. So when C is negative and I multiply it on both sides of this original, the inequality turns around. It turns around. Now AC is greater than BC. Now, does this always happen? What if A and B start out positive? Okay, C is negative. I multiply A by this negative number C. Product over here. I multiply this B by this same negative number C. I will get BC over here. Will it be here or here? Well, the absolute value of B starts out bigger than A. So when I multiply by C, the distance of BC from 0 will be greater than AC, so it's going to be farther away from 0. So again, the inequality did switch. AC is now greater than BC. So this happened again. And then the last scenario is, what if both start out negative and c is negative? I multiply b by this negative number. Negative times negative is positive, so it pops up over here. And then I multiply a by this negative number. Negative times negative again will pop up over here. And since a started out farther away from 0, the product will end up farther away from 0. Same thing. So all three scenarios, when you multiply both sides by a negative number, the inequality, which did say this, turned around. In all the other cases, AP and SPE stay the same. Multiplied by a positive number, stay the same. Okay, so let's try a couple of examples. Okay, so I'm going to approach this the same way I would approach solving an equation. The only difference is if you have to do this. If you have to multiply both sides by a negative number, the inequality will turn around. At that moment, it will turn around. Okay, first step, I'm going to subtract 5 from both sides. That will not change the inequality. And then I will DPE both sides by 2. And there it is. So it's very simple to solve an inequality as long as you don't have to encounter this, because everything's the same as you're used to this. There's nothing different from solving in this than from solving equations. Okay, first I'm going to subtract 7 on both sides. And now I have to divide by -4. So this is the moment when this happens. Since I'm dividing by a negative number, and division and multiplication are the same thing. Remember, division doesn't really exist. So this is when the inequality turns around. And I'm done. So that's the only wrinkle you have to worry about, and that's how it happens. And that's when it happens. Okay, this will be the last example. I'm going to multiply both sides by 3/4 to get rid of this fraction. Eight times 3/4 is 6. I'm going to subtract 5. Remember, this stays negative. And now I'm going to multiply both sides by -2. So it oh, sorry. This was supposed to be an inequality. Both sides by -2, and this is when the flip of the inequality happens. So this -2 will cancel that -2. The inequality will flip, and 1 times -2 is -2. Okay, so that's solving inequalities.